Hi, my name is Jeremy Front, and today I'm going to be doing a presentation on an article I found entitled "In the Ocean, It's Snowing Microplastics." This is primarily based on a primary literature under the title "A Critical Examination of the Role of Marine Snow and Zooplankton Fecal Pellets in Removing Ocean Surface Microplastics." I'm doing this presentation primarily for Bio 182 at Arizona State University. And on the right here, we actually have a small image from the first article depicting zooplankton and some microplastics in the ocean at a microscopic level. Here's the summary of the article. Marine snow is a natural process that has taken place in our oceans since they first contained life. It's not only ancient, but very necessary for any deep-sea ocean life to survive, delivering nutrients down to these lower parts and at times festering bacteria that belong down there. Plastic in the ocean is a major problem that has only been getting worse. It's found that there's up to 10,000 times more microplastics filtering down into our oceans than what we see on the surface, leading to an absolute disparity between the knowledge and what is known about the state of our oceans. Accuracy of the article. I'd found the article actually conducts itself quite well at communicating the primary literature's goal of both research and findings accurately, though it does tend to take the lower end of the numbers that were found, stating as many as 463,000 tons of microplastic went to the seafloor. When the literature clearly states, the figure increased to 4.6 e to the 6 to 1.3 e to the 7 tons, which is a significantly larger range for the amount of microplastic that is sinking to our deepest parts of our oceans and contaminating the seafloor. The article describes the experiment used in another round of trials of producing artificial marine snow, mixing in microplastics and coming to findings that supplement and aid in confirming what was said in the primary literature. On the next slide, I will show an image that is given of that experiment. And in this image, you can see how the experiment was conducted, with large bags housing water being housed inside of a larger pool of water, giving a small blurb that the author had given inside the original article. Huge bags that each contain nearly 800 gallons of seawater that recreated natural water movement in a large pool. Under these conditions, marine snow had formed. Now, this proved in this experiment that marine snow is not just a natural phenomenon and is easily recreatable by our standards. The summary of the literature. In this primary literature, they had discussed the amount of microplastics present in both our surface and the deep parts of our ocean, and how organic marine snow quickens the sinking of these microplastics into our deep ocean. Using the calculations in the simulation, they found that the organic particles take up to 20 particles of microplastic down through the ocean with them, which is about 139% to 393% of what's missing on the surface. What is marine snow? Well, marine snow is traditionally decaying or dead animals, sometimes plants, that filter down and sink through the shallow parts of our ocean into the deepest, serving as food and nutrient for what lays beneath. Specifically in the primary literature, they'd examined the fecal pellets of zooplankton and their effects at the speed of which microplastics can sink to the bottom. The flakes of snow are not only food for these deep-sea creatures, but is also seen to have effects on the Earth's natural cooling processes. This effect on the natural snow has contaminated the deeper parts of our oceans and damaged what remains near the surface as well. And what's causing it? Pollution. It's a major contributor. The plastics that are filling our oceans is because of us humans casting our plastic bottles and our waste to fill these oceans with tons of garbage. These plastics take to the surface of the ocean but break down over time into smaller components like fibers, shards, beads, in which case they start to cling to other particles and sink due to the changes in buoyancy. Animals also have an impact on these plastics moving to the bottom of the ocean, spreading the plastics through the food web by consuming it and passing it on, along with the plastics acting as another ground for bacteria from the surface to reproduce out of their natural habitat much deeper. This article that I found was primarily describing the human impact on ecology, like we discussed in Bio 182. The human impact on this environment has been dire. The deep oceans we thought remained untouched by our pollution has been discovered to have just as much plastic, if not more, than what's present on the surface, leading not only to the damage of this natural ecosystem, but also disturbing the whole Earth by modifying its natural climate and disturbing this natural cooling process. The plastic was found in the species of vampire squids, finding not only the plastic fibers, but beads and fragments laying inside their digestive systems, and once again being re-released right back into the same environment as excrement. Other impacts? It's predicted in the primary literature and the article that the amount of plastic snow is only going to increase with the passing years, and could end up peaking in 2080, in the range of 12,000 tons of microplastic sinking into our oceans. On the figure here, you can see the peak here in 2080. Fecal pellets are much larger than submarine snowflakes, which is only going to accelerate this process, taking more plastic particles with them much deeper, much faster. The sources I used are down below. Here we find the article I used from the New York Times. And right here, the primary literature I used. Credits go to me for voiceover and slides, Jeremy Farrat. Thanks to the General Biology for Majors 2 at Arizona State University, which I took this spring, 2022, for the opportunity to make this presentation. Thanks for the original authors of the primary literature I had used, and thank you to the author of the article as well.